Hello everyone, my name is Tariqul Islam and I am from Tech Waving. So today we're going to build a smart irrigation system using Arduino and soil moisture sensor. So the interesting part of the video is we're going to build an app as well with Node.js. So the idea is to communicate with Node.js and the Arduino. We will get the value from Arduino and we will display it on our front end, which will be built by Node.js server. So let's move on to the computer screen.
So first thing first, to get started, we'll need to install Arduino IDE, Node.js and VS Code. So first thing, Arduino, you can search on Google this and you'll get the official website, and you can download the Windows or the Mac version, whatever you want. Then comes, you'll need to install Node.js on your computer, nodejs.org, and you can download this one, no issues. You'll need to download VS Code to work with the Node.js app. You can download this one. I'm not going to show you how to install this software because these are pretty much easier. Let's move on to the code. Okay, first thing first, I'm going to create a folder for our Arduino app. Okay, I will need to create the file. So you can put whatever name you want. Arduino, the extension will be INO. Okay, this is the extension for the Arduino. You can directly open the software. There is no issues. Okay, just load it. Let me open the file we have just created. It's on a desktop, arduino.ino. Okay, okay, great. Now we are going to start the making of the system. First thing first, we are going to take the relay pin and this is the digital pin where the relay will be connected. Its number pin. Now we are going to initialize the sensor. Zero. And this is the analog pin where the soil moisture sensor is connected. Okay, this is for our system. It might be different on your end. This is just pin numbers. Okay, now let's move on. Output value. We're initializing the variable to store the analog reading from the soil moisture sensor. Okay, now we're going to initialize this function setup. This is for the initializing serial communication at a baud rate of 9600. Then comes the pin mode. pin. It will be relay pin. Output. It will be it will set the relay pin as output. Now we will need to initialize again in mode sensor in. We will use sensor we will use sensor pin as input. Serial. Let's write this text here, reading from the sensor. Okay, when the sensor is working, it will be showing reading from the sensor. Okay, we will set the delay to 2000. Let's save the code. Okay, we have set up the function. Now we will need to run a loop to get the value from the sensor. Void loop. Okay, now we're going to initialize the analog rate output value. Analog rate sensor pin. Basically, it will read the analog value from the soil moisture sensor, and it will store the value on this variable. Okay, then comes output value. Value will be 50. Okay, this is the map, the analog value from the sensor, which may have a specific range to a percentage range of 0 to 100. So that's why we set the value. Now we are going to print the moisture parameter. Serial dot print moisture. Okay, we are going to show our value with this text. Serial dot print output value. Basically, we will read the value and we'll show the output in this variable. Basically, we will print that. Now we are going to add the percentage. Basically, we will show the value in percentage. That's why we need to add this one. Okay, so for we are done here. Now we will need to add a if else condition, cause as you know, we are building a irrigation system, and when the moisture sensor is getting a value, we will set a condition to turn on our water pump. Okay, so let's add the condition output value. Output value, let's set it to 20. If the output value is below 20, the water pump will be running. Basically, it will turn on. If it's not, then it will turn off. Simple. Okay. Digital right. No else. Digital. Okay. Now we are going to add the last function to delay 1000. Let's save the code. Okay. So here our moisture sensor will check if it's 20% less than it's true. It will mean that it will turn on our water pump. If it's not, then it will turn off. And I have added 1 second delay before the next series station starts. Okay, as it's a loop. So far Arduino code is done. We can implement this one on our Arduino system. And now we're going to build our web page in Node.js. So let's start. First, I have created a folder to do all the code on that folder for our Node.js web page. Let me just create our package.json file. So, okay, we will put about all the dependencies, but for formality, we will put some values here. You can just copy and paste from my code. Okay, we will name it apps. Version will be 1.010. Description, we can leave it blank. Will be index.js. Okay, scripts, test, text here. I'll leave it blank, or you can put a name. License will be the same. Okay. Now, the main thing, the dependencies, which are very important. Without this version, we will not be able to make our irrigation system in our Node.js web page. Okay, so make sure you use the same version of the dependencies I'm using. So I'm using serial port, parser redline, and serial port and socket IO. Okay, so these are the version. Make sure you use this version. I can't give you the surety to work with the other version. Sometimes it doesn't work, but this version worked for me. Okay, so Control S, save. Now click on the Node.js, right click on Node.js folder and open the terminal. Now we are going to install all these dependencies and npm install. We're done. So we can see some issues are there, but you can leave it. Let's just fix those by npm audit fix. Click on enter. Okay, so far, yeah, it's done. As you can see, we have two folders. One is for Node.js, another is for Arduino. So we are working on Node.js folder. Now we are going to initiate the other things here. Let's open a file, app.js. Okay, so we're going to do all the code here on our app.js. Okay, as we are using node modules and we are using Node.js, we will need to require some modules from our Node.js. So let me quickly require them. Then comes file system require. Then we will initialize with our serial port. Okay, now okay, we will do the index .html for our file system reading. It's not read synchronize index.html. Now we are going to require our readline parser. I should be getting the suggestion, but I'm not getting any suggestion. I don't know why. Okay. It's coming from our serial port parser readline. Okay. Then comes the parsers serial port dot. We are selecting the parser from our serial port. Then comes constant parser readline parser. Okay, let me think. We're going to use the delimiter 2. No, my bad. Now, okay, I guess. Now we are going to work on our port. Basically we will set some settings which will be connected with our Arduino. We will need to require those settings to be connected with our Arduino system. Serial port, we are requiring serial port. Okay, this is very important. The path will be the same path you were using on Arduino. So I was using COM3. Let me show you. As you can see, when the system is added, I will show you what I was using on our serial port. It will be 1600. Data bytes will be 8. Parity will be none. Stop bits will be 1. Flow control will be false. Okay, we are done with the port. Now we are going to add the parser as a pipeline. Port dot pipe parser, and now we're going to use our app as we're going to use our index.html for our front end. We will need to create the server. So let me just http dot create http dot create server function. Okay, so it will write here 200 to, we will set the parameter to 200, and the content type will be 10. I think this will be the, my bad, I'm having a lot of mistake. It will be HTML. Okay, so far we are done here. Yes. Okay, so far we are done with the code here. Now we will need to add the app.js to our front end. What we were doing, we were working on our app.js. Basically we were connecting with the Arduino system with the COM3 port with our app.js file. So we will get the value here, and we will need to pass the value to our front end. That's why we will need socket IO. So let's require them first. Let's initialize require socket IO, and it will get the app. Okay, so when IO is on, we will get the connection. we'll get the secure connection. Okay, function. I don't know if I'm making any mistake. Yeah, I'm making a mistake. Function socket. Now we will get the value on our terminal console.log that node is listening to port. Okay, so when it's getting the connection, it will show this text, and we will use the cursor on to get the data. And basically what we will do, we will use this cursor to deliver the data to our front end. Console.log, we will show the value on our console as well. So received data from port. We'll concatenate the data, whatever we receive from the sensor. Basically what we receive from the Arduino, and Arduino we will deliver the data to our app.js file, and we will put the same data on our front end. Okay, so that's the plan. So io.emit data. Okay, I think we're done here, if I'm not mistaking anything. Okay, we will need to listen the app.listen to 3000 port. Okay, so I think it's done. I think I'm done with the app.js. So what we will get, we will get the value on Arduino on the COM3 port. So when we turn off the COM3 port from the Arduino serial monitor, we will start getting the value on our app.js, as we are using the same serial port here. Okay, I will show you after the implementation. Okay, so let's move on to the our front end making the the front end web page making. Okay, so let's open a file which will be index.html. So why we are using HTML is basically we are going to use our front end as HTML file, and we are going to get the value from our app.js. We will get the value from the data, and we will move the data from our backend to our front end index.html. So that's the plan. Okay, let me open the shortcut. Okay, as we are using socket.io, we will need to use the socket.io CDN. I will deliver you the link, but for now I'm just using my link here. Just inside the head tag, we'll put the value of the socket.io CDN link. I will deliver you the link, so you don't need to worry about anything. Okay. Okay, now we are going to build our app front end. So div, we will take a div in the class. We will set the class name to parent. Okay, we will create some. This is basically for the design. Class to child one. I'm setting the class name for the elements we have. So we will have h1 tag, and we will bold it. project. So it will be span. Basically, I will change the color of this span. Arduino and soil moisture sensor. Okay. This is just a structure, it's not ready yet. We will need to put the css to check the front end. Let's finish the structure first. Okay, now we will build another div for our child 2. Basically, child 2 class is the very important. We will show the value here. Okay, so I will set a id here with sample. Okay, I think we are done from here. Let's finish the connection between app.js and index.html. Okay, for that we will need to require the socket IO. We can work here by doing the script tag here. We will do our connection here, socket IO. So I have initialized the function. Now we can use this socket. When it is on, it will get the value data and it will run the function data. Okay, so what this get, it will get the console log data. Basically what we get on our data is we are getting the value on console.log the data, and we will put the data on our h1 tag sample. Okay, so basically what we are going to do is we are getting the data from our console and we will push the data to our h1 tag. Okay, we'll put the value here by doing inner html. So let's see how we can do it. We will use document dot get element by id. So we have set the id here sample, so we can use that sample. Okay, so after we push inner html, we will pass the value here. So what value we are going to pass? We are getting the value from app.js is data. Okay, so if we connect this data with this inner html, we will get the value on our front end. It's pretty much simple. Okay, I think we are done here. We have nothing. Okay, we will need to do the styling with css. Okay, so style, I'm doing the internal css. I'm not doing external css for faster work. Time consuming. Margin 0, padding will be 0, box sizing we will put the 0. Okay, so we have class parent, so we will set the background color to, let's say, let me just get the color. Okay, we will set the span tag color, this one, to different color for our project name. So span, I don't know what mistake I'm doing. Okay, as you can see, I'm not using the third bracket. parenthesis. Color will be yellow, let's say. Okay, I'm not that much good at with colors, so don't worry. So we will basically do some CSS here for flags, display flags, for centralizing the design. So flags direction will be column, justify content center, align items will be center. We'll set the value of the width to 100% and the height will be 100 view height. Text will be center. Okay, now we are going to design for our child one. Our child one will be a text aligned center. We will set the padding to 20 px. Color will be white. Okay, we will use child 2 for our. Now we will need to change a little work here, like we will set the width. As we are going to show the value on our child 2, we are going to make a box, so we will need to work a little. Center, we'll set a margin of let's say 8 pixel on all sides. Okay, padding will be 50 px. So we will set the border radius to 10 pixel. Okay, we haven't set the box, I mean the, we can put a border. We will use box shadow instead of border. So box shadow 0 px, px 10 pixel, RGB. You can put your color. I'm just putting my colors 5. Okay, I think we are done. We can check if it's working.
Okay, first thing first, we have already connected the whole system here. So let me just explain you what I did. In the moisture sensor, we have connected our ground with the Arduino ground. Then we have connected the A out with the A0 pin of the Arduino. And another VCC is connected with the 3.3 volt of the Arduino. And again, you can see on the relay, we have connected the IN pin and the 8th number pin. The VCC is connected with the Arduino 5 volt and the ground is similar like the moisture sensor. Ground is connected with the Arduino ground. Okay, and the pump is connected, the red wire is connected with the relay pin and the black wire is connected with the battery. Another wire you can see is connected with the relay pin. So the another wire of the battery is connected with the COM pin and an O pin is connected with the pump. So that's the full connection.
Now we are going to check if it's working or not. So we have the systems ready and the code ready, and I have taken a little water to check if the sensor is working, if it's reading the value. Make sure you select the port COM3, and we are going to verify the code first. Then we will upload the code. Okay, done uploading. So as you can see, the serial monitor is not up here. You'll need to find the option on the tools and select monitor. Okay, as you can see, it's reading the value already. The sensor is reading the value. It's minus 31%. Now we're going to put the sensor into the water. You'll see the changes. As you can see, the value is rising. Okay, so that's how the sensor is working. Now we are going to move the sensor value from Arduino to Node.js app.
As you know, we are using COM3 port. We can't use the same port at a time. Now we are going to turn off the serial monitor. Okay. Now we are going to launch our VS Code to launch the app. Okay, here is our app, and open in integrated terminal, node app.js. Okay, as you can see, now it starts reading the value from the sensor. Okay, so the main thing is we are using the same port on our app also. That's why we had to turn off the serial monitor on our Arduino. So it's a must thing. You can't use the same port with two option. Okay, so that's why we had to turn off the serial monitor on Arduino and start on Node.js app. So as our app is live, we can check on our browser. uh, so it's on our localhost 3000. Here we go, we are getting the value on our front end. Okay, let's try the sensor. Okay, great, it's working.
So that's all the whole video. The purpose of making this video is to help those students from universities who are having embedded system projects like smart irrigation system or anything which is connected with Arduino microprocessor. And I think it might help those students who are having trouble with making app with Arduino. Basically the challenges are making a project with Arduino, but you'll need to show that on our web page. So that's why I tried to help you with all the things I know. If you liked it, please share it to your friends. Thank you so much.